like a difference in temperature. And aren't degrees Celsius the same as kelvins? They are the same size, right? Okay. But for the ideal gas law, we are talking about just the temperature itself. That is the absolute temperature. How much kinetic energy there is. That's why it works. Okay. All right. Example. This is the hardest example. And all these things are, by the way, is you've got to do some diddle before you do this, some diddle for this, some diddle for this. This one's easy. It's always this, right? Okay. And then there's going to be some diddle for this. And this is the diddle is that temperature is degrees Celsius plus 273.15. Okay. All right. So let's solve this one. I've like used all the space on my board. Okay. So a nitrogen cylinder, a diatomic gas, okay, is at a gauge pressure of 90.1 psi. And by the way, almost all pressures that you measure are gauge pressures because we use gauges to measure them, right? Okay. So what do we do with 90.1 psi? Well, we got to add 14.7, don't we? 90.1 plus 14.7. What did we just do? Added the atmosphere. This is the absolute pressure, isn't it? All right, so we get 104.8 psi. Can we use that in the ideal gas law? Well, it's absolute, but it's not pascals yet, is it? Right, so what do we have to do now? Yeah, we got to divide this by 104.8 divided by 14.7. We need to multiply by 1.013. This is what we always do, right? Times 10 to the 5th. Yeah. So we got to turn that into absolute pressure in pascals. And by golly, no, that's the wrong one. Okay, hold on. I thought I had it on my calculator. I don't. Okay, so this is going to be divided by 14.7. Whoops. I think like I tried to edit my last entry. I think that took like longer than just typing the darn thing in, right? Okay, so this is 7.22193 times 10 to the 5th pascals. That seems reasonable. So that's what we're going to put in for this guy, right? Whoops. 7.22193. Yeah? So that's one diddle. We got, I think, 2 or 3 more diddles to do, right? Okay. 90.1. How about 378 liters? Can we use those? No, that unit is 2 liter for us, right? There you go, right? Okay. So how do we convert liters to cubic meters? Is it just divide by 1,000? Yeah. This one's easy, so it's just 0.378, right? Cubic meters. So that's good, right? How about 37? That's a metric unit. We can just use that, can't we? No! No! We must use kelvins. You must use kelvins. Okay. So 37 plus 273.15 is approximately, what is that? Is that 310? Kelvins. Now we're all set, right? So that equals N. R is easy. It's 8.31 always. Right? And then the temperature is 310.15, right? Now what are we going to solve for? We'll solve for N. So take your calculator right now and touch the keys in such a way as to get the answer to this. And that's going to be moles. Do you have the answer? Are you telling me the answer? No. Maybe. No, I don't think so. I think it's about 2.97 kilograms. Okay, so this number, okay, divided by, Braden, get a calculator out, touch it. No brain vacations yet. Do you guys get 105.9 moles? There we go. Well, hold on. No, we're not going to divide. We're actually going to multiply. Right? So 105.9 moles of stuff, but it doesn't ask for moles, so that's the last diddle. The last diddle is we got to turn moles into grams. How do we do that? Well, nitrogen's one of those crazy diatomic molecules, and so we got to look it up. It's 14.007, right? It's the James Bond one, right? Okay. So if the mass is, if it's 105.9 moles, right? I think what we got to do here is we got to multiply by twice 14.007. 2 because it's N2, right? So multiply by 2, multiply by 14.007. And I get that it's 2,967.2 grams. Or sometimes, if you're kind of living on the wild side, you might say it's 2.967 kilograms. And then how many sig figs? We have 3 sig figs. So I guess we'd have to say 2.97 kilograms. If you leave it in grams, I'm very happy about that, you know. Doesn't that seem like a lot? Yeah, you could weigh the cylinder, and feel the difference in the weight because of this gas in there. And nitrogen cylinders, by the way, 90 psi is really not very much. They go up to like 2,000 psi. So like when they're climbing, when climbers are climbing like places where they need oxygen, you can tell the difference between a full and an empty tank by just hefting it. Yeah?
Why is it more mass times 2?
Because it's nitrogen. Remember, nitrogen is one of these guys. Never alone, yeah. Makes a double covalent bond with, I think, is that it? Covalent? Something like that. Hey, we got it right. Try one. What is the volume in liters of, don't laugh at me, 1 mole of nitrogen? Do we even need to know that it's nitrogen? No. You just need moles. 1 mole. I just gave you nitrogen so you'd do something with it, but you don't need to. At 0 Celsius and 1 atmosphere. So can we use Celsius? No. Can we use atmospheres? No. How do you convert atmospheres to pascals? You just use...
1.013 times.
Yeah, there's your pressure right there, right? And then what is our temperature?
Celsius.
It's in Celsius, but what is it in Kelvin? Is it 273.15 is the temperature? Yeah.
So is this going to be like kiloliters?
It's going to end up being in cubic meters. You need to turn it into liters.
Okay. I got this.
What did the court say to the metric unit of volume?
I don't know.
Take me to your liter. I just made that one up just now.
That was a good one.
Are you laughing at the joke or something else? The joke. Okay, thank you. There you go. That's right. Yes. How big, if you guys are talented and gifted, what is the side? If you had a cube, that's right, that had this volume, 22.4 liters, what would it measure on a side? What is the cube root of 0.0224? That's right.
How many grams is mercury?
I didn't know. I didn't need to know grams. This question doesn't ask about grams. I'm talking about moles, and you have just 1 mole. So to do this problem, it's this number is 1, right? This guy's 1. This guy's 273.15. Right? This guy is V. And then this guy is Are you figuring out the side? Yeah. So length times length times length. Yes.